Good morning, good afternoon, good evening, wherever you are. This is Nick Chase, and I am here to introduce today's webinar, which is the Kubernetes and Docker Mini Bootcamp. Today we have with us Andrew Lee as our presenter. Andrew, good morning.
Good morning, Nick.
Good morning. So if you'll push us to the next slide, I will tell people who you are. Yes. So today we have Andrew. He is a technical instructor and a content developer here at Mirantis. He teaches OpenStack, Kubernetes, Docker. He comes to us from earlier roles. He played a QA role in ONOS, which is the SDN controller. He's also been a web developer, which is something that you and I have in common, Andrew. I also started out as a web developer. Yeah, nice. That was probably before you were born. Anyway, so moving on to the next slide, let's do a little bit of housekeeping before we get started. If you've never been to one of these webinars before, on the right-hand side, you will see a little pane that will give you the opportunity to ask questions should you have them. And frankly, it will be there even if you have been to one of these webinars before. At the end of the webinar, we will give you a link where you will be able to download the slides, so you don't need to worry, will I be able to download the slides? The answer is yes. You will also be getting a recording later, so don't panic, everything is fine, so you can just listen and relax, and you will be in good shape. All right, so Andrew, tell us a little bit about what it is we are going to discuss today.
All right. Thank you, Nick, for the introduction. Today, we're mainly going to talk about containers, Docker, microservices, Kubernetes, as well as how OpenStack fits in. So we'll begin by talking about containers and why they are important and relevant in this industry, what containers are. Let's get started on that.
All right, wonderful.
So, what are containers? Well, they're operating system level virtualization. And they're important because, first of all, they have integration with the major cloud providers, such as AWS, GCP, and OpenStack. And
so we really can't ignore them because they're basically going to be there whether we want them or not.
Right, absolutely. And the trend in the industry is to adopt containers over time, so more and more providers will be supporting containers. Containers are more lightweight and efficient. They're more scalable than the full hardware virtualization. For example, they can launch in a matter of seconds, whereas VMs can take several minutes. Now, they're built upon decades of low-level kernel features, which are built up to provide proper isolation and security. And as I mentioned, the trend is to grow containerized workloads and reduce some of the VM workload as well. But it's not a complete replacement of VMs. Rather, they're more efficient means of isolation. So it's ideal for a fast-paced application development and efficient hardware utilization. So what actually are containers? Well, in a typical operating system, you might have a single namespace. So you can run multiple applications on an operating system, but they're going to share all the libraries, the network system resources with each other. So the idea of containers is to extend the operating system kernel to support multiple isolated user spaces. One advantage is that containers, they have low overhead compared to virtual machines. But on the other hand, they generally have less flexibility compared to VMs because the guest will share the same operating system as the host. Okay, if you take a look at the architecture here, on the left-hand side, we have the virtual machine. So they leverage a hypervisor layer, which handles the communication between each of the virtual machine and the host itself. And each virtual machine has hardware and operating system virtualization, on top of which there are packages and applications. On the other hand, on the right-hand side, containerized architecture, it leveraged the existing OS kernel features to isolate each environment. So if you log into each of these machines, actually they will look very similar. Each will have its own processes, networks. They can run services, and you can install packages on them. So a little bit about the history. Now, containers and some of its roots, there's nothing new. It's not a new concept. So one of the first...
You mean Docker didn't invent it?
No. Docker is actually a very new player in this field, so to say. So back in 1982, one of the first container-like feature came from Chroot. And Chroot changes the root directory of a process. And basically, it allows a process to change its children's root directory. So this process can't access directories outside of the defined tree. And this was useful early on for testing and development, where risky code could be run without affecting production workloads. Then you have something called FreeBSD jail, and the jail is basically a system utility of the FreeBSD operating system. It was born from the need to isolate a private host from the customer environment. So this is much like the tenant separation of a cloud that we have today, right? Each jail environment has its own files, super users, and processes, providing full security features and isolation. So now we're starting to get into these container features as we know today. OpenVZ, patched Linux kernel, and it's going to provide containerization features running on a particular OpenVZ kernel. It's fully featured, but limited to a particular operating system. Now, these are all very good attempts at early development, providing isolation mechanisms, but we'll take a look at some of the modern interpretations of how containers are made. So, the latest technologies, they're based on Cgroups and libcontainers. For example, these products, LXC, which are Linux containers, introduced in 2008. It's going to provide a full virtual environment with its own CPU, memory, block I/O, and network, and this leverages Cgroups and libcontainer. Now, Docker, which we'll get into extensively, this is based on Cgroups and libcontainer as well. runC is basically something that leverages Cgroups and namespaces. And they have shared libraries for container images. So we'll get into some of the Docker features later on. Rocket, developed by CoreOS. Now this is known as the credible alternative to Docker, which we won't get into too much details, but this is also leveraging some of the same technologies that we've mentioned.
So the concepts are basically the same for Rocket and Docker.
Yes, they have some different architecture underneath, but the concept and the usage is very similar. Okay, so what are Cgroups? Well, it was introduced back in 2008, primarily by Google. It's a feature of Linux kernel to limit, prioritize, isolate, and account for operating system resources. Now this includes your memory utilization, your CPU, network I/O. You can also run state control, like freeze or restart the process. Now Cgroups can also provide metering as well, which allows you to query for usage information. Now together with namespaces is what these technologies are based on. So namespaces, this is your lightweight process virtualization. Now it does this by providing isolation of many different types, including networks, mount points. You can isolate process IDs, and these are developed over time, over a long period of time. So for example, if a process within a namespace has a particular IP tables rule, another process in a different network namespace is going to have a completely different set of IP tables rules. Okay, so we have a chart here. So you can see that starting from 2002 all the way to 2016, there's more and more type of different namespaces being added to the Linux kernel. Okay, for example, yes.
These are namespaces that are just included with Linux, basically.
Yeah, absolutely. So, for example, what does it mean to have a process ID namespace? Well, this means that the PID namespace can only see processes within that namespace, and they're assigned with their own numbering system, starting from 1. All right, so container adoption in the industry. According to DevOps.com and Cluster HQ, they surveyed 316 people, and 79% of the participants reported using container technologies in the organization. A surprising 76% also use this in production. Now keep in mind that the source is from DevOps.com, so a lot of these users are already familiar with the container technologies, but the trend is to grow this adoption, to increase developer efficiency, and to support the microservices architecture. So majority of them are running Docker and other technologies as well. Some will run these together, so if you add these up, they're over 100%. So Docker, LXC, Rocket, Jails, and Solaris Zones, these are some of the names you may hear in this space. Okay. So before we get into Docker, I want to talk a bit more about the Open Container Initiative. Now, this is an initiative established in 2015 under Linux Foundation, and it's an effort to standardize the way that containers are built, unpacked, and run in an execution environment. So Docker is actually one of the main contributors to this initiative and follows this standard very closely. Now it's going to be composed of 2 main specifications. You have runtime spec, outlining how a file system should be bundled or unpacked on a disk. And you have the image spec, how to build, transport the image into the file system bundle. So briefly, the image spec, this is going to define how interoperable tools should build, transport, and prepare the image. The image manifest is going to describe the configuration, the set of layers for a single container image, and its operating system, for example. The image layer, the change set, is the basis for using layered file system to present multiple independent layers that come together to form a cohesive file system. You have the image configuration, defining immutable JSON descriptions of the image attributes required to launch your container. You have the runtime spec. This is going to describe the interoperability of the runtime, the execution environment, and the lifecycle of the container. So these are your standard container operations defined in the configuration file. All right, so it's going to look like this. All right, so a very simple key value pairs describing a high-level description of what the container should look like and what it should run and how it should run it. Okay, with that said, we can talk about Docker. Now in this section, we'll describe what Docker is, what is the big deal with Docker, and how it works. So Docker is not simply a container. It's more than that. It's a containerized application deployment tool. So you have some components within Docker. You have the image, the repository, and the runtime container itself. Its real benefit is in the image creation and distribution feature, and the ability to easily layer these to create a reproducible environment, reproducible development and production environment. So it relies on the union file system, and you can also have the ephemeral file system. So there's something called a Docker file. It's a notion in Docker which allows users to define image creation with a simple developer-friendly text doc. Okay, and in this, you're basically going to define the base image. This can be something like your Ubuntu 14.04. You declare the deployment procedures, then you build and save the image. So now you have a reproducible container instance every time you launch from this new image.
So let's kind of stop there for just a second and give
Sure.
a more concrete example. So this layered file system that we're talking about. So I might have, let me have you check me here for a minute. So I might declare, say, I'm going to start with a Ubuntu base, and then the Docker file might say, now deploy Nginx, and then now go and copy these files into the HTML directory for Nginx. And then what I wind up with is an image that will be a web server. Is that correct?
Yeah, so your image that you defined in your Docker file is going to build the way you described it. And if you want to deploy your web service, you can do that by specifying those images that you got from the repository.
Great. And then somebody can use that image as a base for their own stuff?
Right. And therein lies the main advantage of Docker. Is easily portable, and anybody can take that image now and build the reproducible environment.
Ah.
Now, this makes the developer an integral operations member. Okay. So as an example, we mentioned you have the from statement. It's going to indicate your base image. In this case, our 14.04 Ubuntu. And this will be fetched from Docker's or your private image repository. You have the run statement here. It's going to run some arbitrary command. We're going to get, update, and install our Apache, as well as clean some directories here. And we can expose a port. Since it's our Apache is our web service, we're going to expose port 80 for HTTP request. And then we can run the actual Apache process itself.
Aha. So you've got a good deal of control here.
Yeah, absolutely. And it's very simple to do as well.
Okay.
So the hype around Docker is around its ability to solve the CI/CD problems of operations team, and this is referred to as the integration matrix problem. You have multiple developer machines trying to develop, compile, and test code. Then you have multiple infrastructure to deploy it on, and then multiple cloud providers as well. So there's many different versions of Linux components that need to come together to properly deploy a cohesive application. So using Dockers, developers have solved this problem. They are declaring their small building blocks wrapped as Docker files, and now these can be deployed anywhere. You define it once, and you run it anywhere. That's the idea. Now the application model. So how should we define a container? What's an ideal container look like? Well, the rule of thumb really is to have one process per container. It's not necessarily a steadfast rule. And applications running in a container should be as ephemeral as possible. So if you've ever heard of pets versus cattle, you should treat it as a cattle, something that can go away and come back at any notice, but it should not affect your application. In a container, you shouldn't have unnecessary packages. You shouldn't install something just because you can, or it's nice to have. And then the idea is that the developer can carefully define the container and its contents, like packages, the services, and then they put it together. The operations team now has a flexible sort of black box, sort of say, container unit that they can take and reproduce into a test or production environment. So this leads us to our next topic, which is microservices. And in this section, we'll talk about the intersection between DevOps and containers, which we describe as microservice. So when we talk about DevOps, we're talking about the practice and tools, which increases an organization's ability to deliver applications and services with agility. So in a traditional DevOps model, you've had environment and virtualized environment and configuration management tools, which work together to produce a product. The developer would commit a code to the repository. It may trigger some job in the config management tool. And then that tool integrates and tests the code, right? It's known as your continuous integration. And then that tool may also deploy the code somewhere in a production environment, let's say. This is known as your continuous deployment. And this worked fine, but there's a lot of overhead. So in an automated application deployment, in this architecture, you have multiple small services, many layers, and smaller applications and dependencies that need proper orchestration to coordinate your process. So applications, they were typically sort of composed within a single VM with all these layers of services and dependencies. Now, Docker is trying to alleviate this complexity associated with this application deployment. So that's why people started adopting Docker. And there's something called a 12-factor application. It's your methodology. And it's describing, well, the methodology declares that in order for software to be delivered as a service, you should have several things. You should be able to have a declarative format for automation. You should have maximum portability across different environments. Should also be suitable for deployment on cloud platforms. Okay, and developers should be able to easily define these and package it and deploy it anywhere. So Docker actually perfectly fits into this model, this modern way of deploying applications, because you can easily define the environment using Docker files. They're portable, as we've seen, and it's designed for the cloud platform in mind. And in Docker, there is a DevOps packaging tool, we can think of it, and it's known as Docker Compose. It's where you can define and run multiple containers on one host. And these containers will share volumes, they'll share networks, environment variables. All the developer needs to do is define the compose.yaml file, and the operation team can set the overrides for this production deployment. And you can think of this as Docker's way of microservices. So as a summary, traditionally you may have a model where applications and services live on one host or a virtual machine on the left-hand side with its own set of dependencies and libraries scattered across a single host. On the right side, we can leverage containers, deploy each piece of the application stack in an isolated and lightweight box, which can easily be deployed across various types of hosts. So the application management at the container level allows us to really embrace the DevOps model. So if we think about sort of a full application example, we have a web service here. So at a minimum, you may have 3 servers. You have the web server to serve the request. You have an application server, which is hosting your application, and a database, persistent database server. Now, given what we know about Docker, we can, in theory, deploy all these services in a container. But it's going to take a lot of work, right, to manage those containers and all the configuration. How do we keep track of the network information? And what if I want to scale out these containers? What would I do then, right? What if I want to add load balancing features? What happens if one of my containers dies? Who's going to restart those containers? And all those questions are actually what we're going to answer next. It's a higher level program. We're talking about container orchestration. But before we do that, we have a poll.
We do indeed. Thank you. Listen, I just want to say I'm going to go ahead and launch this poll in a second, but I want to tell everybody that we see a bunch of questions coming in, and that is terrific. Keep them coming. We will be answering them at the end. So just because we haven't answered them yet, we promise we are not ignoring you. So we wanted to take a minute and ask you guys, what kinds of courses that you think would be useful. So we've been talking about containers at this point for a few, for up to this point, and then we're going to talk about orchestration with Kubernetes after that. But we want to make sure that when we're creating courses, we're doing courses that are something that you're going to be interested in. So please take a minute and drop in your answer here. If you're under other, let us know in the chat what you would like to see. So if you're hitting other, please go ahead and tell us in the chat what that other is. Otherwise, we're just going to die of the curiosity. And you don't want to kill us, do you? I hope not. So far, I will tell you, DevOps appears to be the far and away favorite, but considering that this is a webinar on containers, probably not that much of a surprise. Second place, we have NFV for OpenStack, which is also not surprising, but there is also a significant contingent here that wants to see some machine learning for developers, which is my sort of obsession at the moment. So go machine learning. Yeah, so I'm very, I see a couple more people voted for that. Thanks so much. Anyway, now that I'm trying to influence the results, I don't want the training department to come and get me because they know where I live. But anyway, so we'll just take another minute or two and allow the results to settle in. And let's see what we're coming up with on the chat. Oh, we've got people dropping it into questions. So someone's asking about orchestration. Somebody wants to see container orchestration in OpenStack. Yes, thank you for the support for machine learning there. Okay, so let us go ahead, and I'm going to go ahead and close this out in a second. I think we've pretty much, I'm going to close it out in like 5 seconds. So if you want to vote, now's the time. And then we're going to get back into Kubernetes. So now that you had a little brain break, let things sink in, we will go back to our discussion. Okay, so thank you all so much for voting on that. We appreciate that. All right. So moving right along. Oops. Thank you, Andrew. All right, we'll go back to Kubernetes. So you were saying that Kubernetes is about orchestrating containers.
That's correct. So we can think of Kubernetes as the container orchestration platform. So Kubernetes treats containers as a first-class citizen. At a very minimum with Kubernetes, you can declaratively schedule and run containers on physical or virtual nodes across multiple cluster of servers. So Kubernetes sort of goes beyond just simple orchestration doing A, B, and C. It continuously works to transform the current state into the desired state. And the desired state is going to be achieved by leveraging additional Kubernetes features like auto replication, auto restart, and auto scaling. In Kubernetes, there's a notion called pods. This refers to your smallest unit of deployment. And inside a pod, you may have one or more containers, but they should be closely related. You can consider a pod as a microservice. Now, containers within a pod, they share the same namespace, like a network namespace. So they are able to trivially communicate with each other. And containers within the same pod actually share the same IP address as well as port space. And they can see each other using localhost. Containers within this pod, they should have access to the shared volumes. And they also share fate as well. If the pod dies, then all the containers within that pod will die. You can think of pods as sort of an improved Docker Compose, if you will. You also have volumes in Kubernetes. So it's important to note that volume is just an abstraction. Kubernetes will support the management of multiple types of volume services, like Ceph file storage, GlusterFS, iSCSI, or even AWS, Elastic Block Storage. So the notion of a volume, this indicates just a directory stored somewhere on a disk provided by some volume service. And this is also shared between containers of a pod. In Kubernetes, you also have labels and selectors. Labels, you can label your objects with an arbitrary key value pair. So an object could be a pod, it could be a node, and the selectors are in charge of returning matched objects of a query. And this is heavily utilized by self-managing operations. So for example, you may label a node with disk type SSD, and then in the pod configuration, you can define a node selector. Say, I want the SSD disk type node. And then the pod will be deployed on that selected node. You also have a service. So far we learned that a pod is tightly coupled group of containers, and those containers can have volumes of different types, like Ceph and EBS. We also learned that you can label these pods using a logical endpoint. So now we'll talk about service. This is your network access to a logical set of pods. So when you're grouping pods together to form a cohesive application, you have a policy to access them. We need this abstraction because although the pods have IP addresses, the pod object itself is ephemeral, and you can't rely on those for consistent access. And a service is also discoverable by pods through DNS as well. Now, lastly, you have Kubernetes controllers. Controllers, they ultimately drive our application to a desired state. So it's responsible for enforcing and maintaining the declarative deployment. So there are many types of controllers with deployment, replica set, stateful set, demo set, etc. But deployment controller is likely what you're going to use in your application. You can deploy a desired number of replicas for your pods, declare a new state, or even roll back to an earlier version that you've tagged. So to initiate deployment, you actually simply just define the deployment YAML file, then you run the kubectl create command on the deployment file, and this workflow applies when creating other resources in Kubernetes. So that's Kubernetes in a nutshell. It's a very high-level overview with some of the features. But you can think of it as a, if you consider it a new operating system of the cloud, then the pods are the new processes. It's going to define your deployment unit. Docker is your new app repository, or your packaging and the deployment unit. And the container is your new VM. It's going to isolate your portable deployment units. So in terms of OpenStack, can OpenStack and Kubernetes exist, and what are some of the use cases? Right? Well, there's many, but we'll take a look at two quick approaches today. The first one you can think of as the best of breed approach. This is going to leverage the best of both worlds, running stateless applications on Kubernetes, and you can leverage OpenStack to manage your stateful services, like a Galera DB cluster, for example. Maybe you want to do something really out there, develop applications for your SDN solution on Kubernetes, and then have that communicate with your SDN controller through APIs. And secondly, you can have Kubernetes on top of OpenStack. So in this model, OpenStack is the underlying platform for deploying and managing Kubernetes, as well as traditional VMs. So if you're not completely familiar with OpenStack, it's comprised of many programs. It's not a single solution or product. OpenStack is a composition of programs. So in this example, we have the Magnum program. It's going to make container orchestration engine like Kubernetes available to OpenStack. And it will leverage the heat program to orchestrate the image that contains Docker and Kubernetes. That's why you're seeing Magnum pointing to these Kubernetes nodes. And it's going to deploy it either on a VM or bare metal in a cluster configuration. Now, Ironic just helps us provision these bare metal nodes. And lastly, you have Nova program, which is going to manage your traditional virtual machine workload. And all of this is done through a platform with a unified API. It's going to give you a plethora of options. So that's going to be it. I'm going to hand it off to Nick now. Nick, are you there?
Yes, I'm here. I'm here. Sorry, I was muted. Let me
No worries.
Go ahead and grab this back. All right, I'm going to show my screen. All right, so first of all, thank you, Andrew, and thank you for not killing me for being on mute. Anyway, so that was great. So that was a basic introduction to Docker and Kubernetes, but there's a lot more to talk about, obviously, in terms of Docker and Kubernetes. So one thing that you can do is if your interest was piqued here, we do have a couple of other Kubernetes and Docker classes. These are full classes, obviously. There is the Docker Kubernetes and Docker Bootcamp 1, or the KD100 class. That's the sort of basic beginner class. It's a 3-day course. It's instructor-led. You can do. They also have self-paced formats now, which I think is terrific. Gives you the sort of basics on how to deploy these applications, how to run them, how to manage them, and so on. There is also a certification exam, the KCM 100. It is included with that course. Certifications are becoming a huge thing now because there's so many technologies out there. It is always a good thing to be able to prove what it is that you know or don't know, as opposed to just coming in there and being like everybody else, just saying, oh yeah, I can do that. Well, prove it. Also, there is the KD200 class, which would be the Kubernetes and Docker Bootcamp 2, which is once you've finished KD100, it just kind of continues on from there. This is also a 3-day course. This is also instructor-led. In terms of certification here, you may have heard about the new Certified Kubernetes Administrator exam from, I believe it's CNCF, the Cloud Native Computing Foundation. And this is the course that prepares you for that CKA exam. So if you're interested in either of these classes, we do have a special offer for you, just as a reward for sticking around to the end. If you want to use the code Mirantis which apparently is how you pronounce that. I did not know that until a couple of days ago, that K8s, which is short for Kubernetes, is actually pronounced Kates. Who knew? Anyway, if you register before the 31st, we will go ahead and give you a 20% discount for you since you were here. And by the way, again, that's all of the Kubernetes and Docker courses that Mirantis provides. So that's a sort of overall Kubernetes and Docker discount. So if you want to see all of the training courses that we have, you can go ahead to training.mirantis.com, and you'll be able to see what all the classes are. So let's go ahead and jump into the Q&A. If you want to download the slides, you can see the URL there. I'm going to go ahead and Andrew, you're going to answer these questions. Let me just kind of look through here for just a second and see if there's any that I can answer really quickly. Somebody wants to know, what do I get with the self-paced class? So the self-paced class is you get the course materials and the video, so it's video based, so you get access to that for a full year. You have there's extensive hands-on labs, of course, and you have 3 days to do the labs. And again, you still get the an attempt at the KCM 100 exam. There's a discussion board for that lets you talk to other students and to the instructor and all of that. And of course, whether you take the exam or not, you do get a completion certificate. So there is, so that's the information on the self-paced class. We will get into the technical questions in a minute. I just want to kind of get any logistical questions out of the way. Let me see what we have here. Is KD100 for entry level or more advanced technical users, and what are the prerequisites? So KD100 is mostly for novices. You can see the prerequisites. If you go to the training site, training.mirantis.com, we'll throw the link into the chat, but you'll be able to see what the prerequisites are. So I think that is it for logistical questions. Andrew, you ready to jump into the technical questions?
Yeah, let's do that.
All right. Is persistent storage available for containers? So you did talk a little bit about ephemeral storage. Talk to us a little bit about persistent storage. How does that work?
Right, so in a container, well, inside that container's file system, you might have ephemeral storage, but you can actually create and mount persistent volumes, which is living outside of the containers. And that's the way to do your persistent storage.
So basically you would create the volume, and then whatever you put on the volume, once the container goes away, or in the case of Kubernetes, the pod goes away, the volume is still there. So if you attach it to a new container, it'll see that data.
Right, that feature depends on the volume provider as well. So if you, for example, use Elastic Block Storage from AWS, it's going to be able to do that for you.
Okay. And I know that one of the volumes you can use is also like a Git repository. I know that because I'm actually writing a blog on that right now. So keep an eye out for that if you're interested.
Awesome.
So, all right. And while we're on that topic, so I know somebody asked about, how do you handle situations where you need that persistent storage, like if you're doing a database, and you talked a little bit about that in the OpenStack section. You want to kind of elaborate on that?
Sorry, can you ask the question?
Sorry, somebody asked also, I'm not seeing it here in the list, but I remember seeing a question go by where someone was asking, well, how do you do applications where you need something persistent like a database or something like that? Now, you covered that a little bit in the section on OpenStack where you've got stateless and stateful. Do you want to elaborate on that just a little bit?
Right. So with Kubernetes, you can have that as well. So you would have the database that is managed by Kubernetes volumes.
Okay. Yeah. So your non-ephemeral data basically would go in a VM as opposed to in a container.
Sure. Yeah. Absolutely.
Gotcha. Okay. So is Docker or Kubernetes stable enough to run applications in production?
Yeah, of course. There's many production cases that are running Docker and Kubernetes in production. Even banking institutions, the features are secure enough for them to run it as well.
Okay, so it's and you're kind of that's kind of a big point there. Like I know, so we're following a lot of the Kubernetes stuff. So like on Monday, I plan to be putting out an article on what's new in Kubernetes 1.8. And some of those features are not going to be final. They're going to be alpha features. So you need to really kind of pay attention to what features you're using to know whether or not it is stable enough for production. So we can't just say, yes, all of Docker is stable and all of Kubernetes is stable, because that's not necessarily true, right?
Yeah.
Okay. All right. When you declare a base image, say Ubuntu in the Docker file, does that mean that the image will load the entire OS and then apps on top of it?
Well, the app layer, you would define yourself. How is your application looking on the image? So the base image is coming from the repository, but that repository is going to only define that operating system, and then you're going to add image layers on top of that.
Okay, and
yeah.
what are necessarily in those image layers?
So these can be your services that you're installing using apt. So we saw in the earlier example, we installed Apache. For your base image, it's your basic operating system, and typically it's something like Ubuntu and so on.
Now, okay, but it doesn't have to be Ubuntu. It could be actually an image, and we talked about this earlier. It can be an image that someone else created. So if somebody creates an Nginx container or any other container, there's literally thousands of these containers and base images that are available in, say, the Docker Hub, right?
Absolutely.
Okay. So, and there's also versioning for these containers. So when you go to set your base image, you can specifically say, oh, well, I want, Nix Nginx 3.2.6 and go from there. So you have a good deal of control over it. Okay, let's see. We have, someone says, it seems that most of my customers who are deploying containers are deploying Kubernetes alongside OpenStack. Can you talk about this sort of deployment? Are there caveats? Is Neutron sufficient for virtual networking in this sort of environment, or do you see value in tools such as OpenContrail?
Right. So to answer some part of that, they're deploying Kubernetes alongside OpenStack because they have multiple types of workloads that they're running. Their application or development process may be more efficient on Kubernetes. They may have some SDN or NFV solutions that only work on OpenStack virtual machines. So it really depends. As far as networking solutions like Neutron, does that do everything? I don't know. Maybe you can answer that for us, Nick.
Well, I mean, my understanding, and I could be wrong on this because I'm not a networking expert, but my understanding is that Neutron can work. I might be totally wrong on that, but I do know that we have been doing a lot of work with OpenContrail in Kubernetes. So there's definitely value in those kinds of tools. So let's see. So I mean, I'm trying to come up with a good example. I'm trying to come up with a good example. I can't, but I will tell you that I know that there's a lot of work. There's a lot of work in container networking right now. There's the container networking interface, right, on for Kubernetes. So there's really a lot going on. Let's see here. We've got a couple more logistical questions. Can we apply the discount to registering for the exam? Apparently that is only for the training itself. So, but for the KD 100 class, it comes with the exam free. So I guess technically speaking, it's for the training also, but not for the CKA exam. What about the on-demand course? Yes, the discount applies to all of the Kubernetes and Docker offerings from Mirantis, so you can use it there. Let's see here. We have a couple of other questions on like which training courses. And I'm going to have to kind of refer those over to the training department. Let me see if I can get them to answer them before I open my mouth on them, because I don't know the answer. So let's see if we can get them in there. I've forwarded those over. Let's see what other questions we have here. Do we have to rewrite all of our traditional apps in order to run and scale on Kubernetes?
Well, the simple answer would be not necessarily. You can, in theory, deploy your traditional app just like you would on a virtual machine. But what's the point of that, right? I mean, you want to run a microservices, the best modern way to deploy an application. In that case, you would want to divide up your application into these smaller chunks and deploy it on containers to fully really take advantage of the containerization.
Okay. Yeah, I mean, so and there's a whole sort of methodology for breaking up these monolithic applications to be cloud native, right?
Mm-hmm. Mm-hmm.
Yeah. Let's see. Can you elaborate on Magnum? You want to take that, or you want me to take that one?
Magnum, well, you can go ahead on that one, yeah.
Okay, so Magnum is a sort of orchestrator of orchestrators when it comes to containers in OpenStack. So Magnum allows you to use OpenStack to orchestrate Kubernetes and I think Docker Swarm and I think Mesos as well. Again, don't quote me on that one because I could be totally wrong, but yeah, so that is something that you would use Magnum for. So Magnum basically allows you to more easily manage your Kubernetes deployment in this context. Is it the easiest way to do it? I don't really know that I would necessarily say that. There are lots of other ways to do that. I know in Mirantis Cloud Platform and MCP, we do a lot of orchestration, I think, outside of Magnum, if I am correct. So that is that question.
With OpenStack, I mean, you have so many different programs.
Oh yeah.
So I find that the best thing to do is really check out the OpenStack documentation. and that'll answer more in depth about what you may be looking for. And if you're not familiar with OpenStack, we also have courses on that as well.
Absolutely, absolutely correct. And the same goes for the question, is Magnum production ready? You really need to. I don't actually know the answer to that because I think it changes. I think that answer changes. You know, based on what you're trying to do and what version are you using, and
right. The community is so dynamic. There's a lot going on and multiple communities coming together.
that is very true. We heard about a new version of Kubernetes that will soon be available, Kubernetes 1.9 or 2.0. What kind of features will be available? The next version of Kubernetes is actually 1.8. And it is intended to be a more of a stability release than you know, lots and lots of new features. And I believe, I could be wrong, but I believe that I'm saying that a lot in this webinar. But I believe that that is also the case for 1.9. They have been really introducing a lot of new features over the last few releases, and they're trying to just kind of say, all right, you know what, we got a lot of alpha features right now. Let's try and clear those out before we start adding additional technical debt. All right, so the training department answered a couple of our more logistical questions. So let's kind of go back to these. Which course do you recommend for me? I am a network architect. And the training department says both KD 100 and KD 200 would be appropriate. You need to know Linux, and you can check the prerequisites on the course page, which if we can get, which hopefully we can get them to drop into the chat, or you can just see it on the course page. Can you please tell me if the recordings in the on-demand courses are kept up to date? Oh, yes, they say, yes, we are doing regular updates. So, and that's a good thing, because in the course of the year when you'd have access to those recordings, oh my God, a lot changes in a year. So, all right, so let's see. It is 2 minutes before, let's say 1 more minute to answer one more question, and then we'll put the rest of the answers into a blog. So are the images in the Docker repository safe to use? How do we make sure they're not compromised?
Well, so with any sort of public cloud providers, let's say you're using Amazon, and they have image repository as well. So you're going to sort of have to trust that it's safe and not compromised. However, you know, if you are very concerned, or if you'd like to have your own repository, Docker supports private image repositories as well.
Right, and even if you are, I would recommend that if you are using a public repository, the one good thing about this Docker file structure is everything's visible. You can see exactly what's being done. So take a good look at that Docker file. See what the base image is, see what's being done to it, look at the code. You know, in today's world, you cannot be too careful. And if it's, you know, even if it's being based on another image, you can go look at that image and see what that's based on. So definitely go ahead and do your own due diligence. Okay, so we are at time. We do have a few more questions, and like I said, we will go ahead and drop them into a blog. But thank you. I want to thank all of you for taking the time to be here with us today. We know how busy everyone is. I want to thank Andrew Lee, our instructor for today. Thank you so much, Andrew, for joining us and giving us all this great information.
Thank you, Nick.
And I want to thank the training department for making you available and for also helping us out with some of the answers to these questions. And as always, our extraordinary production support on the back end, Michelle Yakura, without whom we could never do any of this. So thank you all, and we will see you next time.